Hello everyone, today I'll showing how to design pile cab in Breeze. Here is the design of pile cab for Breeze. The pier of the major flyover bridge transmitted a load 84 kN, 0 kN at the foundation level, and width of pier is 1 meter and length of pier is 9 meter. Hard starter soil is available at depth of 6 meter below the ground level of bridge side, and pile bearing capacity is 660 kN. Pile dia is 200 millimeter and length of pile 6.6 millimeter and spacing of piles 1.5 meter and compressive strength of concrete 20 MPa and yielding strength of steel is 415 MPa. Design the pile cap. As a given data already, we know the pier load, pier length, pier or width, pile dia, pile length, pile bearing capacity, spacing of pile, and compressive and tensile strength. And number of pile, we know 1.1 dead load plus live load divided by pile bearing capacity. So we need the uh, 14 piles, and load on each piles is total load divided by total number of piles, which is 600 kN. So the arrangement of pile cap is very important. We have shown the 440. Here is the in one side is 7, 1, 2, 3, 4, 5, 6, 7. In another side is 7. Okay. So LX, we know how this is the arrangement is very important. Arrangement is very important. So LX equal to 0.75 into 2. 0.75 is clear distance into 2. 1.5 into 6, as we have used 14 columns, 14 piles, which is 7 piles. Here is 1.5 into 6 is 6 is the spacing of the piles, and we have found 10.5 meter in LX, X direction in 10.5 meter, and LY will be 3.5 into 3.5. Here is a 3.5, 1 meter and 1 meter, and 0.75 and 0.75, 2 and 3.5 meter. Okay. So x1 this is the CG. X1 is a first pile distance from CG, whereas 1.5, if you know the 1.5 minus 0.202 minus 202 is a 200 is a pile dia divided by 2 into 2. That's why we have got in this way, in this distance x1. And the same way x2 is CGT, and going to the dispersion, this will be x2, 1.5 into 2, 1.5 into 2 minus this is the column 200, and this is the pile dia, and column pile dia, where is our pier dia? Pier is 1 meter divided by 2 into 2. In the same way x3 will be here, and this is the x3. y1 is 1 meter, y1 is 1 meter, and pile cap size 10.5 meter into 3.5 meter. This is the pile cap size. Now we will calculate the moment. P is a total load divided by total number of piles, total divided by total number of piles, and 2 is the first row of the piles, 1 2. If we get in 3, then we will put this value in 3. x1 is the distance of first row of the pile cap. Here is the x1, and P divided by total load divided by total number of piles into another 2 is the second row of the pile, 7. I'm using this. In the same way, second row of the piles, there is a 2, and P divided by total load divided by total number of piles divided by another 2, which is x3 into x3. Here is the third row, 1 2 3, third row third row of the piles, and if we get is 3, then we will multiply 3 instead of 2, so we will get 108 kilonewton meter. My in y direction the movement, total load divided by uh, total piles, and number of row of the pile. If we have seen the 7 piles in y direction, and y1 will be cg2 pile cap, cg of the pile cap distance, and we have found 4200 kilonewton. Okay, so punching of the shear, we know the punching of the shear is occurred d distance of d by 2. On the other hand, flexural shear is occurred distance of d. This is the memorizing we have to put in mind. Okay, so flexural shear, we know the total load divided by total number of piles divided by 14. Why we have this 14? Because we know the 14 piles are out of the C plus D. Here is the C plus D. C is a pair, and D by 2 and D by 2 we have found the here is a 7, and here is another 7. That's why we have put the 14 and found 8400. Aero perimeter A 4 into C plus D, 4 PL plus D into D, PW D plus D into D, which is 2 and 2 is a 4 n into D. Okay, so we have found here, and the equation of punching shear 4 into 5 into root over f times CFP, putting this value and found this equation. So this we can say that this is 1 and this is 2. So we have, if we putting equation 1 and equation 2 left and right side, then we found 31 millimeter. On the other hand, we have see here the flexural shear, which is occurred at the rate of distance of d. We know the total load divided by total number of pile, which is and multiply into 7. Why we have 7? Because the shear is occurred at the distance from D. That's why we have used only 7. Okay. So in this way the one way of flexural shear 2 into root over f times B into T. B is a 3.5 into 100. 3.5 is a breadth of the pile cap, and found this. This was 3 equation, and this was equation 4. Okay, so solving equation 3 and 4, and found D equal to 179 millimeter. So thickness of pile cap we have found 31 millimeter from punching shear and 179 from flexural shear. But we have calculated here for putting value of D, but D does not satisfy. That's why we have given trial again and again, and found this value, which is we have provided 2000 millimeter. Okay, reinforcement calculation of long direction, which is LX 10.5 meter along the 10.5 meter. Here is the M. M equal to rho b square Fy1 minus 0.59 rho Fy by F times C, and found the rho is 0.00 0066, which is greater than the minimum rho, which is 0.20. We know another, we have found another slide is, which is 0.0181. Another slide we have found the minimum reinforcement 0.00018. But I have found here for especially in bridge for S2 go to have found 0020. Okay, so minimum reinforcement 132 00 millimeter square per meter. If we calculate the reinforcement in another method, here is A is equal to Fy, as Fy by frequency B, and putting this value, just unknown is As, and we have found and 0.024 As, and As equal to Mx divided by Fy d minus A by 2. Here is A equal to putting this value in A, and found the reinforcement, which is 13188 meter square, which is very closer to this value. This is value. So we can use this formula for calculating reinforcement, or we can use this. I have shown that both of the calculation. Okay, let's see. So using 22 millimeter main bar, so if the area of 22 millimeter is 864 millimeter square, so spacing will be 61 or millimeter square, which is b divided by s divided by as, and we have found 61 millimeter or 6 millimeter. So number one, we have found 32 millimeter main bar at the rate of 61 millimeter center by center along the direction of 10.5 meter at the bottom of the pipe. So this is our first output. We have putting this main reinforcement along the 10.5 meter. But I have analysis another here. So what if we change the dia? Suppose we have change the dia of 1200, then our reinforcement will be 28800. If we change the dia again 1500, then our reinforcement will be change 19177. If we change the 1820 1800, then our reinforcement will be 18993. So if the reinforcement has been decreasing, if the increasing the depth, so we have seen here increasing the depth, but reinforcement has decreasing. So this is the very important. So if we increase the thickness of the pile cap, then our reinforcement will be decreased, and spacing will be also increased. Okay, so this is my another analysis, so you don't need to hear. I just analysis here. Okay, so reinforcement for short direction, as we found my and rho bd square Fy1 minus 0.5 rho Fy by Fmc, and putting rho 0.026, which is greater than 0.002. So as 5200 millimeter square per meter, rho as equal to rho bd, which is 5200 millimeter square. Okay. So another method, if you use the another method, equal to as Fy point Fmcp and 0.022 as, and as equal to my. There is the my is the moment of the y direction. We have found here two type of moment, mx and my. We have used the my 4200 and found 5224. So this reinforcement and this reinforcement almost similar, so we can use any kind of formula. So I'll prepare this formula. Okay, so spacing we have used again 32 millimeter bar, so area of 32 millimeter bar is 804, and spacing will be into as divided by as, and we have found 155 millimeter, which is 6 inches. So we can see the 32 millimeter main bar at the rate of 6 inches center by center in short direction, which is ly 3.5 millimeter at bottom of the pile cap. Here is the reinforcement calculation. We have found this. If we see this figure, we have found this type of reinforcement. One is 32 main reinforcement bar, 61 millimeter center by center. Another one 32 millimeter center by 32 millimeter main bar at the rate of 155 millimeter center by center. Now we will check the minimum reinforcement we will provide at the top or linkage reinforcement or distribution reinforcement. So we will calculate the distribution reinforcement bar, which is um, 0.12 divided by 0.12 divided by BD, um, which is called 0.12%. 0.12%, 0.12% of reinforcement we will provide at the top, where we have found that this is the S2 port or port requirement. That's why I have putting this value 112 into BD, and found 2400 millimeters using 25 millimeter distribution bar. So area of 25 millimeter is 419 millimeters. So spacing B into S divided by S is, which is 205 millimeter square or 8 inches center by center. So 25 millimeter distribution bar, 8 is center by center at both direction at top of the pile. Here is the top of the pile. I have already notify that the top of the both direction we will use this. So this is the final lecture. So if you have any question, you can ask me. I have already analyzed why we have changed the depth of pile cap. Because of this analysis, if we increase the depth, if we increase the depth, if we increase the depth, then our reinforcement will be decreased. Our reinforcement will be decreased, and the same way spacing will be increased. So this is our main reason. If we increase the depth, then our reinforcement will be decreased. So that's why we will trial and error again for exacting for getting an exacting value of depth or depth of pipe. And another important talk was punching shear, which is occurred is d by t distance, and the flexural shear which occurred is d distance. So at first punching shear is occurred d by 2 distance. That's why we will use 14 piles. As we know, C by D into C by D, which is called C. All the piles are situated out of the C plus D distance. On the other hand, if we see the flexural shear, we will calculate that D piles of which is situated distance from distance from D, from CG of the pipe here. That's why we have used 7. I hope all you have understand my talk. If you have any question, then ask me.